Okay, guys, today we need to talk about MHF4U Unit 4 mid-unit assignment. Okay, so from above, we have a graph of what? Of the temperature throughout a year, from January all the way to December. So the question asks, determine the trigonometric equation that modules this information and let the y be the temperature in degrees Celsius and x be the numerical value of the month. Okay, so how did we do that? So we have a maximum 21 and we have a minimum negative 24. So in order to get the number right in the middle, we use 21 subtracted by negative 24 and we'll get a 45. We used 45 divided by 2. So maximum plus minus minimum divided by 2. And then what we get? We get a 22.5. So as that, we would say that it has been vertically stretched by a factor of 22.5. And then from the graph, we can see it's a reflected in the x-axis, and it used to be a cosine graph. So a cosine graph reflected by the x-axis. So since we have the maximum value 21 and we have the minimum value 24, so minimum value 24 and that's 21 up there, both of them have 1.5 distance away from the point 22.5 and negative 22.5. So therefore it has been shifted down. It's been shifted down 1.5 units. So it gotta be there and now it's here. So 1.5 units down. And it's supposed to be here and that goes there, so it's 1.5 units down. So then we would say it has been stretched by a factor of 6, and why is that? Because there is 12 months. So a cosine x function's cycle is about 2 pi, and since we have horizontally stretched by a factor of 6, what we will get? We will get the function above, the function here. That would be negative 22.5 cosine 1 over 6 x plus 1.5. And then for the second question, okay, so we have a Ferris wheel, has a diameter of 10 meters, takes 24 seconds to make one revolution. So the lowest point on the wheel is 1 meter above the ground. So what we do here, look at this. We have a Ferris wheel, 10 meters, 1 meters. That's the ground, that's the diameter. And then we need 24 seconds to complete one revolution. So for the first question, we need to sketch a graph to show how a rider's height above the ground varies with the time as the Ferris wheel make a rotation, assuming the person started the ride at the lowest point on the wheel. So thinking about this, we start the wheel here. We go one revolution, so in the middle of the graph, 12 seconds, since you gotta use 24 seconds to complete one revolution. So you start at 1 meter. You go 12 seconds later, you will end up at 11 meters. Because that's 10, that's 1, and that's 11. 10 plus 1, 11. Okay? And then, after the 24 seconds, it comes back. So that's 1 meter again. So what's the minimum point? That's going to be 1 meter because that guy is on the Ferris wheel. And what's the maximum point, or what we call the local maxima? It will be 11 meters. So look at the graph here. We have 1 meter, that's from 0 seconds. We have 24 seconds, which is still 1 meter. And then we have 12 seconds. At 12 second points, we reached our local maxima. where is that? Right here. That's 5 meters, which is the radius. 5 meters here, and then we have 1 meter here. Okay, so 1, 11, 1. Then we come to the question B. Write a trigonometric equation that describes the graph. So the A is equals maximum minus minimum divided by 2. And equals 11 minus 1 divided by 2 equals 5. So the K, which is period, cycle, 2 pi divided by period. 2 pi divided by 24 equals 12 over pi over 12. And we'll do the C. It is maximum plus minimum divided by 2, which is 11 plus 1 divided by 2 equals 6. And we have our thing, the equation here. The h of t, which is the height of time, equation equals -1 cosine bracket pi over 12 times t bracket back plus 6. That's our equation. And we check the accuracy of the equation by using t equals 12 seconds. Explain why this provides a check of accuracy of the equation. What are 2 more values that would provide a good check? So we substitute 12 seconds into t ht function, which is that -5 cosine pi over 12t plus 6 equation, and then we get h of 12 equals -5 cosine pi over 12t plus 6 equals -5 cosine pi over 12 times 12 plus 6 equals -5 cosine pi plus 6 equals 5 plus 6 equals 11 meters. And this value provides a check of accuracy because at this time the Ferris wheel is at its maximum height, and the other 2 would be t at 6 seconds and t at 18 seconds. T at 6 seconds because look at that, it's right at the center of here. It's look at this. So 0 seconds it's here, and then out of 6 seconds it's right here, and 18 seconds it's right here. So it's right in the middle point of the Ferris wheel. Yeah. And then we move on to the question number 3. The height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meters at 2 minutes and 2.08 to a height of 17.3 meters at 08.21 measured with a 24-hour clock. Oh, okay. Then that's 2 o'clock, 2:08, and that's 8:21. So assume the height of the tide can be modeled as a cosine function of the time of the day, and then we determine the equation of the form, which the form got to be h of t equals a cosine k t minus d, and then we plus c. So since we have a, which is maximum minus minimum divided by 2 equals 17.3 minus 4.5 divided by 2 equals 6.4, and we have our period, which is 2x. We have 8 o'clock 21 minus 2 o'clock 08 equals 12 and 26 over 60 hours, which is 373 over 30 hours. And we have our k, 2 pi over period. We have 2 pi over 373 over 30, which is 2 pi times 30 over 373 equals 60 pi over 373. So we need to calculate the c and the d. So the C is maximum plus minimum divided by 2, which is 17.3 plus 4.5 divided by 2, which is 10.9. And the D is 2 hours and 8 minutes. What is that 2 hours and 8 minutes? That is 32 over 15 hours, if we use that form over there. Then we combine the A, K, C, D, and of course the period. Well, we will get the h of t is negative 6.4 cosine 60 pi over 373, and then with t minus 32 over 15 plus 10.9. That is done. And then we substitute the t equals to 11.3, and then we need to get our answer to the nearest 0.1. So we substitute t equals 1130 here. So h 1130 equals negative 6.4 cosine 60 pi over 373, and 23 over 2 minus 32 over 15 plus 10.9, and then we get this. So we do the thing here and then we times that. We will get a negative 6.4 cosine 2 pi over 373 times 281 over 1. Then we plus 10.9. So we use that, we plus that, because the left part will end up with negative 0.1 meter, and then we get 10.8 meter. So how about next? We have a boat needs a depth of at least 12 meters to dock at the pier. Use a graphical approach to determine when the boat is able to dock and when it must leave. So we have h of t equals 12. Remember the function we done here? The function right here? We put 12. We put 12 here. And then we get 12 equals negative 6.4 cosine 60 pi over 373 bracket t minus 32 over 15 plus 10.9. We do the calculation here. We move that here and we divide it by that, and we divide it by negative 6.4. We will get negative 11 over 64 equals cosine 60 pi over 373 t minus 32 over 15, and then we have 1.7435 equals 60 pi over 373 with t minus 32 over 15, and then we take that out. We take this thing there. We get 3.4501 equals t minus 32 over 15, and then we move the 32 over 15 over there. So this equals this plus that, which is t equals 5.58. What is 5.58, you may ask? We just do a calculation. 5.58. 58% of an hour. That's 35 minutes. And then, therefore, the T1 is 5 o'clock, 5:35. 5:35 in the morning. And then we have our T2. T2 is 8:21 plus 8:21 minus 5:35. So we use 8:21 plus 2 hours and 46 minutes. So 8 plus 2, we get 10 o'clock. And then we have our 21 minutes plus 24 minutes. So we plus 1 o'clock to the 10 o'clock, which is 11 o'clock. And then 1 plus 6, which is 7. we have 7 minutes, so that's 11, 7, which is 11 o'clock, 7 minutes. So 11:07 in the morning. So the boat, we will come to the conclusion right here. So the boat is able to dock since 5:35 and must leave before 11:07 a.m. That's both a.m. Okay, that concludes my MHF Unit 4 mid-unit assignment. Thank you.